A two-way frequency table or contingency table is used to show frequencies of data from a survey or experiment classified according to categories, with rows indicating one category and columns indicating the other. Notice if you just look at the bottom there, it's just basically a table that is used to describe the frequencies of, it could be a survey or any type of contest or grades, or it could be about anything as long as there are two different types of categories. So on real world example 1, organizers at Lincoln High School are planning a new student center. They surveyed freshmen and sophomores about the types of games they would like to have: video games, board games, or table sports. Students were asked to select only one type of game. The results of the shown in the table. Of the students who chose table sports, how many of them are freshmen? So if we look in the table and we see that in the table sports row, how many of them are freshmen? So this is the table sports row right here. And the number of table sports that are freshmen is this 30 right there. So the answer to this would be 30. Of the students who chose, how many students chose video games? So the total number of students that chose video games would be right here. This whole row represents students that pick video games. So the total number of students that picked video games was 190. How many students are freshmen? So the number of students that are freshmen is going to be this column right here. This is all the freshmen. So the total number of students that are freshmen are this total, which is 105. The next question is how many students were surveyed in total? So on a frequency table, two-way frequency table, there are two ways to find the total. You could find the total of the freshmen and sophomores in each column and then add those together, and that would be the 500, so that would answer that. Or another way is to find the total number of students who did video games, board games, and table sports, and then add that column together, and that will also equal 500. So the rows totals going this way and the column total going this way should both add up to the same number in that cell, which is 500 in this particular case. One teacher suggested the budget for student centers should be split evenly between freshmen and sophomores. Another teacher disagrees. What argument can be made? I think the most logical argument on this is that the budget should not be split equally, simply because there are more sophomores than freshmen. So you can say that should not be, the sophomores have more people or more students, therefore they should get more money. That would be the most logical argument that I can see being made on this. So there you can see how to read a frequency table. We can also complete and construct our own frequency tables. In this situation, a small town conducting a survey to help decide on which community initiatives they should spend annual funding. The town has 2,400 residents who responded to the survey. According to the survey, 45% of respondents are cyclists, of whom 80% enjoy spending time at the lake. Of the residents who are not cyclists, 75% enjoy spending time at the lake. Make a two-way frequency table to display the data. So we do have 2,400 residents, and that does say that in the total column or the total row, whatever the case may be. The first sentence that talks about the number of residents in each cell is 45% of respondents are cyclists. So if there were 24 total respondents and 45% of them are cyclists, we can figure out the total number of cyclists in this column here, or this cell here, by taking 45% or 0.45 times 2,400. And when you take 0.45 times 2,400, you get 1,080. So there were a total of 1,080 cyclists. Then it goes on to say, of whom 80% enjoy spending time at the lake. So The cyclists that enjoy spending time at the lake is this cell right here, the one I just X'd. So 80% of the cyclist respondents enjoy time at the lake. So we're going to take 80% times the total number of cyclists, which was 1,080. So 80% or 0.80 times 1,080 would give you 864 cyclists enjoy the lake. Now, since we know how many cyclists enjoyed the lake is 864, and we know the total number of cyclists is 1,080, we can figure out the cyclists that do not enjoy the lake by subtracting. Take 1,080 minus 864, and we would get 216 cyclists do not enjoy the lake. Another thing we can fill out is the non-cyclists total. The non-cyclist total is this green box right here. So the non-cyclists would be the 2,400 total respondents minus the 1,080 that are cyclists. So 2,400 minus 1,080 would give us 1,320 non-cyclists. We can continue on. Of the residents who are not cyclists, 75% enjoy spending time at the lake. So we have 75% of that 1,320 enjoy spending time at the lake. So we can figure that out by taking 75 times 1,320. So as I quickly type that in my calculator, I get 990. And we also know that since there are 1,320 non-cyclists and 990 enjoy the lake, the remaining must not enjoy the lake, so that would be 1,320 minus 990. So we have 330 who do not enjoy the lake. Then we can finally just find our totals for the enjoy lake, not enjoy the lake. So our total of cyclists and non-cyclists that enjoy the lake would be 1,854. That's found by just adding 864 plus 990. And then those who do not enjoy the lake will be 216 plus 330. That's 546. And notice that when I add this column together, or this row, 1,854 plus 546 does give us this same total of 2,400. A relative frequency table is the ratio of the number of observations in a category to total number of observations. Basically, we are talking about percentages. You could use decimals in there, but most often we're going to see this written as percentages. So we can compute all of the respondents by dividing by the total number of respondents or total number of people that are associated with the study, and that will be a percentage. Some parts of a relative frequency table have specific names. The subtotals in each category are called the marginal frequencies. Data which shows percentages for joint situations where two categories intersect are called joint frequencies. So the total of each column or row, but not the overall total, the total of each column or row is a marginal frequency. A joint frequency is going to be the number that is in a particular cell. For example, a manager of a gym conducting a survey to determine whether the gym members prefer rock climbing, weightlifting, or neither. She also asked members whether they regularly bring guests to the gym. The frequency table shown below shows the surveyed respondents of the surveyed members. We're going to take this information and make a relative frequency table by converting the data in the table to percentages. So the total number of respondents is 200. So all of these will be divided by 200 and then converted to a percentage. So for example, the weightlifting that brings guests, that is 86 divided by 200. When you take 86 divided by 200, you get 0.43, and then convert that to a percent would be 43%. So weightlifting bringing guests would be 43%. Whereas if we have weightlifting that do not bring guests, that would just simply be the 2 that's do not bring guests weightlifting divided by 200. That is 0.01, and that would give you 1%. So you're just taking, in this particular case all of the cells divided by 200 and converting to a percent. And I'm going to do that very quickly right now. And there's the rest of the table that's been filled out. So notice that this column and this row, the total row and column, do add up to the 100%. On occasion, I will say that sometimes they don't add up to perfectly 100%. Due to rounding, it is possible it may add up to 101% or 99%, depending if you have to round a lot of the totals up or a lot of the totals down. Even if you go to the 10th place, you might see that they round to 100.1% or 99.9%, but it should be close to 100%. Part B asks to find the joint frequency of rock climbing and bringing guests. So joint frequency of rock climbing and bringing guests. This is not relative frequency. Relative frequency would be the percentage table. We want the original table, which is rock climbing and bringing guests. So we're going to go to the cell that represents rock climbing and bringing guests. And bringing guests and rock climbing is this cell right here, 24.